Although explosive eruptions that form calderas are among the most violent natural events on Earth, they are rare. Therefore, the tools available to determine the height of ash columns from previous eruptions rely on measuring the thickness of ash sediments and their particle size. Essentially, larger ash columns leave thicker deposits at greater distances from the eruption source, with pumice, broken magma, and lithics, rocks torn apart by the eruption, gradually decreasing in size with age. By measuring these parameters in the field at various locations around an eruption, scientists can estimate the height of an eruption's ash column. If there are distinct layers within the ash deposit, this technique can even be used to determine whether the eruption's height fluctuates over time. For example, scientists can see that a major eruption that occurred about 3,600 years ago from Santorini volcano, Greece, began with an ash plume 10 kilometers 6 miles high that later grew to 30 kilometers 19 miles. For reference, the cruising altitude of most aircraft is 9 to 12 kilometers 30,000 to 40,000 feet. This is why calculating the height of ash plumes from previous eruptions is important for understanding the potential impact of future eruptions on aviation. For volcanic eruptions as large as Yellowstone's largest caldera-forming event, ash plumes likely reach the top of the stratosphere, which is 50 kilometers 31 miles above the Earth's surface. In the 1960s, geologists Ray Wilcox and Glenn Izzett created ashfall maps for previous Yellowstone eruptions by traveling across the western United States, identifying Yellowstone eruption deposits by their chemical composition, and measuring characteristics such as their thickness. These maps played a crucial role in understanding the characteristics of the ash column from Yellowstone's massive and catastrophic eruptions. If you live in one of the many states covered by these deposits, you can visit these locations by searching for them on the map created by Wilcox and Izzett, which includes coordinates and field descriptions. A group of geologists from Montana State University and Victoria University of Wellington, New Zealand, recently visited one such site near Shell, Wyoming. At this site, two ash deposits associated with two identified Lava Creek tuff ash flow units, which formed during the formation of the Yellowstone caldera approximately 631,000 years ago, have been reported. However, the geologists also discovered something else. This basin, located in the Bighorn Mountains, not only contains the aforementioned deposits, but beneath the older Lava Creek tuff deposits, there are two additional ash deposits not listed on the Wilcox and Izzett map. What are the possible sources of these additional thick ash flows in central Wyoming? Could it be ash from the Mesa Falls Tuff, 1.3 million years old, or the Huckleberry Ridge Tuff, 2.1 million years old, also from Yellowstone? Or could it be ash from a more distant location, such as the Bishop Tuff eruption, which formed the Long Valley caldera in California about 767,000 years ago? The presence of biotite mineral crystals in one of the mysterious deposits suggests Bishop ash as a possible suspect, since this mineral is not associated with major Yellowstone eruptions. But what about the older ash? To find out, geologists sent samples of the mineral sonidine from each of these deposits to the U.S. Geological Survey at Moffett Field, California, for dating using argon geochronology. The results will provide information about the age of the eruption that triggered the ash deposition, thus informing geologists about its possible source. We don't yet have an explanation, but we'll let you know once the results are in. The ground above the Yellowstone supervolcano sits on a hotspot made of molten and semi-molten rock called magma. As magma enters the magma chamber, or reservoir located about 6 to 10 kilometers, 4 to 6 miles, beneath the park, the ground swells. As the magma begins to solidify and cool, the ground sinks. Volcanologists, who have been measuring this activity since 1923, say the ground rose about 25 centimeters, 9.8 inches, between 2004 and 2009. However, in 2010, the ground began to sink.